Now we'll discuss about the protection schemes. So various protection schemes are overcurrent protection, distance protection, carrier current protection, and differential protection. So first is the overcurrent protection. So here overcurrent protection exists when current exceeds the rating of conductors. There is an overload in a condition in which the equipment or conductors carrying current exceeding their rated capacity. So short circuit, unintentional electrical connection between any two normally current carrying conductors of the circuit is line to line or line to neutral fault. So during the ground fault, dangerous voltages and abnormally large currents exist. Next is the distance protection. Distance protection relay is the name given to the protection whose action depends on the distance of the feeding point to the fault. That is, the impedance between the relay and the fault depends on the electrical distance between them. That is, the principal type of distance relay is impedance relay, reactance relay, and reactance relay. That is, distance protection the principle differs from other forms of protection because the performance does not depend on the magnitude of the current or voltage in the protection circuit. The current element produces a positive or pickup torque while the voltage elements has caused a negative and reset torque. That is, the relay operates only when the ratio of voltage and current falls below the set value. So here the voltage at the potential transformer region depends on the distance between the power transformer and the fault. So the distance zone is not non-unit protection. That is, the distance protection is high speed protection and simply to apply. And distance relays are used for both phase fault and ground fault protection, and they provide higher speed for clearing the fault. So they eliminate the long clearing times of the faults near the power source required by overcurrent relay if used for the purpose. Next is the carrier current protection. So this is mainly used for protection of long transmission line. So here the phase angle of the line decides whether the fault is internal and external. The receiver converts the received carrier current into the DC voltage and can be used in the relay or other circuit that performs any desired function. So the trap restrict the carrier current to the unprotected section so that to avoid the interferences from the with our other adjustment carrier current channels. So the coupling capacitor connects the high frequency equipment to one of the line conductors and simultaneously it separates the power equipment from the high voltage line voltage. And the different methods of current carrier protection are directional comparison protection, phase comparison protection. Differential protection is one of the simple conceptual technique, that is compares between primary current and secondary current of power transformer, and the relay will actuate an intertrip between both the primary and secondary circuit breaker of the transformer. So in other words, secondaries of both transformers should be connected to the same current coil of different delay in such an opposite manner that there will be no resultant current in that coil. So to correct the phase shift of the current between star delta connection of the transformer winding in the case of three-phase transformer, the current transformers secondaries should be connected in the delta and star connection. So this is schematic diagram of differential protection scheme. So at maximum through fault current, the spill output produced by the small percentage unbalance may be substantial. Thank you.